Today I'm going to show you how to build a simple electronic kit. It's an audio level display. It simply shows the intensity of audio signal in using square LEDs. So I've heated up the soldering iron, so I'm just gonna get started. So what I usually start with is the resistors. And the silk screen shows what resistor goes where. So we start with a 1 kilo ohm resistor. 1 kilo ohm, that's brown, black, red. And after that we have a 100 ohm resistor. That will be this one, brown, black, black, black. This one is actually a 1% tolerance resistor, which means it has 5 rings instead of 4. So that's why it's a bit weird. They're usually also this turquoise color, so you can usually tell them apart from, in that way. And then I will have 1K again, and that's again brown, black, red. And another 1K, 1 kilo ohm. Like so. And then 2.2 kilo ohm, that will be red, red, red. Here we have that one, red, red, red. And the last one, gold, is just the tolerance. Gold means 5%. So it's could be plus minus 5% from 2.2 kilo ohms. And then we have 10 kilo ohm, and this that will be brown, black, orange. Quite easy to mistake for the 1 kilo ohm, because orange and red often looks very similar on these resistors. So take care to don't get it wrong. And then we have 10 ohm, that is brown, black, black. Like so. Then the last one, it's a 20 kilo ohm resistor. It should go, let me see. Oh yeah, it's a bit weirdly mounted. It's actually right underneath the main chip. And normally you wouldn't be able to mount anything below or underneath a chip like this. But in this kit, the IC is mounted in a socket, and the socket has this groove in the middle, which means the resistor will fit just barely there. So those are the resistors placed in it, in the PCB. Now I will solder them. The main trick to get a good soldering joint is to put the tip of the soldering iron on one side of the lead, so it touches both the lead and the pad, and then you touch the solder to the other side. So you should never really let the solder touch the soldering iron directly. That will just burn up the flux. And also you could end up with a bad soldering joint because of the flux being burned up. And also if you haven't heated up the lead and the pad enough so that you can melt the solder, and you melt it on the soldering iron instead, that means we'll have a blob of solder that doesn't really attach to the pad and the lead. So there we have it. All of the joints fixed, and then let's cut off all the leads. I usually say these cutoffs so I can use them for well, bridging pads when doing prototypes, for example, or just general bridging between connections. Quite useful to have. There we have it. The resistors are mounted. Now let's move on to, let's see, I think the capacitors. These are ceramic capacitors. 104 they say. 104 actually means they are use the same scheme as the resistors, with the first numbers meaning the actual value and the last digit meaning the number of zeros following it. So 104 means actually 10 and then 4 more zeros, which is 100,000 picofarad. They are measured in picofarad normally. So 104 means 100 nanofarad. There we go. And cut off the leads. Just above the soldering joint. Okay. And now let's go over to the LEDs. The resistors and capacitors doesn't matter the direction of. Well, not for ceramic capacitor anyway. The LEDs, however, have to be mounted in the right way. And they actually well, have sort of arrows on this circle mask. But also each LED is marked with a plus, meaning the anode goes in the hole which is marked with a plus. The anode, that is a positive lead, is usually the long lead of an LED. So we just place it like so. Also, when in doubt, you can also look into inside the LED, because if you look at it closely, let's see if you can show it here. They have a sort of big anvil on one of the leads, and yeah, let's show it here. There's a sort of anvil thing, and then the other lead is just a small one. And the anvil is where the chip is placed, and that is almost always the negative connection. Also, round LEDs have a sort of flattened part on the cathode, the negative lead. Yet another cue to show which is plus or which is minus. Okay, those are the LEDs. I will flip them over and solder them. What I usually do now is I solder one of the leads for each LED, so I can easily adjust them, because I will probably get them a bit crooked here. They might not be put down firmly towards the PCB. So if I solder just one of the leads, that makes it easier to adjust. Like so. Oh yeah, oh, very crooked. So what I do now is just push the LED down and touch the soldering joint to make sure that it's the LED is pushed down firmly towards the PCB. Turn around, otherwise I'm gonna burn myself. Oh, and of course I shouldn't let go until it has cooled enough to be solid again. There we have it. Yeah, just need some straightening out, but that is easy to do afterwards. And I will solder the second lead for each LED. One there. Like so. Yep, looks fine. And they're all mounted in the right way. So I'm going to cut off the leads. There we go. Now let's move on to the IC holder. I think I should have done that before, but oh well, that's fine. So this one actually places over the resistor, and the resistor actually, yeah, you have to push it down. It will snap into place. This is quite handy actually. That means it holds the socket down while soldering it. Again, I usually solder the corners and then make sure it actually is mounted properly. This time it was quite easy since the resistor holds it in place. Then I just solder all of the pins, the leads. I got my soldering iron set quite hot, so it's easy and quick to solder, because I've done this a lot of times. But if you're not very good at it, or if you're a beginner, you might have it slightly lower and it takes longer for each soldering joint, but it will be safer. Because if you have too hot and you heat it for too long, the components could break from the heat. There we have this IC socket. As you probably saw, there is a sort of marking in the silk screen, and there's a corresponding cutout in the holder, which just shows the orientation of the chip. And then the chip has a similar cutout as well, just so you can make sure that it's put in the right way. If you put it in the wrong way, it will probably burn up the IC, so be careful. And now I will mount the, let's see, that's right. I will mount the sockets for power and audio in. Like so. Just gonna check if it's the right way around, but it's going in that way. So red is up. Yeah, that will be the right way. Again, I solder one pin and then I make sure it's firmly set onto the PCB. Like so. And lastly, we have, well, almost second to last, we have the variable resistor, the potentiometer. This one is used to set the sensitivity. And it doesn't really matter which way you put it in, so just put it wherever you want. However you want, at least. And again, sort of one pin, and then I'll push it into place, like so. There we go. I'm going to cut off the leads. And lastly, we have the chip. We just push it in, making sure the orientation is correct, and then push it into the socket. You might actually have to bend down the leads slightly inwards, just very slightly, so it will go into the socket. Like so, and there you have it. Okay, so let's try this out. I've connected the audio level meter to power. It uses, I think, around 9 to 12 volts. I set it to 10 volts. And then I connected a simple adapter, which connects to my laptop, which just gives out audio. So hopefully we'll see something. So I turn off on the power first. Nothing happens, but then I turn on the music. See? Oh yeah, there we have it. And then you can set the sensitivity using this potentiometer. You can, let's see which way it goes. I think that increases the sensitivity. And then we can go down. It's a 10-turn potentiometer, so you have to turn it a lot of turns for it to change. But yeah, now it's very insensitive. So let's turn it up somewhere halfway. Like so. Now it is a bit flickery, and that thing, the reason for this is that the chip, as it's set now, will just keep one LED on at a moment, which means that the LED will just move back and forth, the one that is lit. But it has a mode where it actually lights all the LEDs up to the level, and that you can turn on by shorting out these two pins here. So that's what I'm going to do. So I'm turning it off, like so, and I'm going to carefully put in, take one of these cut-off leads. This is one of those times when it's get handy to have these spares, and I just put it in here, like so, and then let's soldering it. So let's solder it properly here, so, like so, and then cut off the excess, like so. Let's see now. Yeah, that's better. As you can see now, the lower LEDs are much more solidly lit. Before it was mostly in the middle, you can see the most intensity was that's where the LED was mostly lit. So now we have a really nice audio level meter. And if you build two, you can have a stereo. So actually I have one more. I can show you how that would work. So let's connect power. Okay. This could be tricky. Actually, I'm gonna do like this. Let's take two more of these cut-offs. Use them for power inputs. Like so, and then we'll connect, let's see here. This could be a bit tricky. Have ground, minus. These aren't exactly made to be put into a breadboard, but let's make it work. Like so. Now that one came out. Like so, and then we have these again, ground, or minus if you prefer to call it that. Really doesn't want to go in. Yeah, that is not a good thing. Let's make it easy. Let's use even more of those cut-offs. So I will take this, we have, let's see, those are the ones for power. I need a third hand or fourth hand here, so I'm gonna use this helping hand as it's called, very aptly. I'm just gonna solder a stiffer lead to it. Like so, then we have plus and minus, and then the plus. Doesn't have to be neat, it just needs to work for now. Like so. Hopefully I don't need it for the audio connection, we'll see. Anyway, there we have power to it, and now we connect the black for audio input to the ground of the audio, and then we put the red to the other channel. There we go. Now let's see. I don't know if they're probably not set up to exactly the same sensitivity, but we'll adjust that. See, there we have power on, and yeah. And there you have it, in stereo. Pretty neat. I think this one is actually set up slightly more sensitive than that one. Hard to tell because I don't know exactly what the audio level for each channel is, but yeah. No, that's the wrong way around maybe. It will take some tweaking, and you probably want to even measure the resistance of them to make sure they are exactly the right way around. That seems to increase. I thought that the direction was decrease. Okay, let's turn it the other way around. Oh, there we go. That's more like it. So yeah, so, close. Yeah, that's probably about it. So there you have it. Stereo audio level indicator. Pretty neat.